Thanks, Karen. So yeah, just to introduce ourselves there, we're looking at this progression in fraction knowledge and skills. My name's Sarah Leakey and Andy Thomson's with me here as well. I'm going to be doing a lot of the presentation. Andy's going to come in the end, but if you've got any questions, please do put them in the chat and Andy will be able to respond to them there. Just to give a bit of background, certainly myself and my colleague Julie have been doing quite a lot of work in Ireland on fractions over the last few years, and we're hoping to put out a progression at some point in the not too distant future related to this. So this is just some of the work that we've put together, including quite lengthy discussions with Andy, and working with lots of different schools across Highland. We do work quite a lot with schools that are part of the Scottish Attainment Challenge and also those that are using pupil equity funding. Apologies for the pinging sound in the background. That'll stop after people have all arrived and everything. So just to look at the aims, we're going to look at some common difficulties with fractions, understanding the meaning of fractions, fractions as numbers, and we're going to look specifically at the measurement subconstruct in this session. Don't worry if that doesn't make sense, it'll hopefully make more sense as we go through. Karen, I've just thought, is this recording?
Yes, I'm on it this time, Sarah.
Perfect, thanks. So I just want to start off with an example from a secondary pupil and ask the question whether we're kind of, our aim is for pupils to get answers or to develop a deeper understanding. So this pupil had this problem involving subtraction of fractions, and their words were, I can't remember what to do. So they were looking for a procedure there. They did eventually just to sort of remember what the kind of steps were that they'd been told, and this might look quite familiar to people, and then they were able to solve the problem. They then went on to solve some other problems involving mixed numbers and improper fractions as well. But what was interesting is that this word problem that they got given here, they were able to determine what they needed to do as a result of the word problem. That wasn't the difficulty. The difficulty was that they didn't know how to add the three fractions because it didn't, the procedure that they'd been taught didn't work in this situation. So my question is, are we going for answers or understanding? And hopefully we'll be able to kind of tease out how we can get both through some of these ideas here. So the other thing I want us just to sort of consider at the beginning of this is whether all fractions mean the same thing. So if you take this example here, there are 8 sweets, you get 1/2 of them. How many sweets do you get? What's the 1/2 referring to in this problem? So is it a number as in a quantity, i.e. it's 2 Smarties or 3 Smarties or whatever that is? Or is it a relationship between 2 quantities? Well, this 1/2 isn't referring to 1/2 of a Smartie. It's this relationship between 2 quantities, between the number I get and the total number there are. And so then this question is quite an interesting one. Is 1/2 always equal to 1/2? I've posed this to both children and to in CPD sessions that I've delivered, and it always sparks quite a bit of a debate. So let's just look at it again in the context of those sweets. So Sarah got 1/2 of 8 sweets and Andy got 1/2 of 16 sweets. So 1/2 is not equal to 1/2 in this situation, in the sense that I only get 4 sweets, but Andy gets 8. But they are the same in the sense that they represent the same relationship. It's 1/2 of all of the sweets. So just to illustrate that point about the meaning of the numeral, that fraction, or in this case, the whole numbers in these problems, if you take this, Sarah has 8 sweets, Andy has 16 sweets, how many are there altogether? And then consider this problem, Sarah has 8 sweets, Andy has 2 times as many sweets as Sarah, how many sweets are there altogether? You can see that this 8 is the quantity of sweets, it's how many Smarties I get. This 16 is the same, but this 2 isn't about how many Smarties I get. It's describing a relationship between the number of sweets that I have and the number of sweets that Andy has. So that's what that 1/2 was doing in a similar way in the other problems. So do our pupils understand that numbers can have different roles within these problems? This was an equal sharing problem that some pupils had been given. So you have 3 cakes and you share them equally between 6 people. This is a variety of different answers we got to that problem. So this pupil said they get 3 pieces each. This person said they get 1/2. This person said 2/4 or 1/2. And this person said 3/6. So we've got 3 different fractions being referred to in this problem. So again, the question is, do they all mean the same thing, or are they different? And what do they represent? Is it a number, i.e. how many cakes I get? Or is it a relationship again between 2 quantities? And do pupils understand that these all represent the same number? So in this situation, we are talking about how much cake I get compared to 1 cake. So if we look at that on a number line, for example, if this represents all 3 cakes, then one person's share, someone described that as 1/2. That's where that sits on a number line. Someone else described that as 2/4. That also sits in the same place. And somebody else described that as 3/6, which also sits in the same place. So how much do our pupils understand about this idea that these 3 different fractions that look different actually represent the same number? We've got a similar equal sharing problem here. 8 children sharing 7 brownies. You can see the pupils working out here, and then they've described it. So they've described it as 7/8 of 1 brownie, that's one person's share, or 7/56 of all the brownies. So now this appears to be 2 different answers, and these are not equivalent fractions. So 2 different answers to the same problem. So how is that possible? So again, if we look at what these fractions represent, that first one, 7/8, sits about there on the number line, if we consider this to be the 7 brownies that we've got. And 7/56, if we were considering it in the same type of way, would sit over here. But that isn't what this pupil is meaning by saying 7/56. They're describing this 7/56 in comparison to all of the brownies. So it represents the same quantity, but it's describing it in a different way. So my question is, do our pupils understand these differences, or are they just producing a fraction and not really kind of knowing what it means or what it relates to? So if we take that same example there, we're thinking about, or this pupil's thinking about comparing it to different referent wholes. So in this first situation, the referent whole is 1 brownie. But in this second situation, the referent whole is all of the brownies. In both situations, one person's share is the same. That doesn't change. The thing that changes is what you're comparing it to. So he said that they get 7/8 of 1 brownie, or 7/56 of all of the brownies. And that's quite a level of detail that I think a lot of our pupils don't necessarily have, and partly due to the way that kind of traditionally how fractions are introduced and explored with pupils. To illustrate that point a little bit more, I've got a think board here. And pupils were asked to kind of explore these fractions in different ways. Here they were asked to represent each fraction in its own rectangle, and the pupils managed to do that fine. Over here, they've also had to order them from smallest to largest, and they seem to have done that fine. But what I find most interesting, and this happened in every single example that I gave to the pupils in terms of this number line, is sometimes pupils were able to identify 1/2 here, but if you look at where 1/4 and 1/8 goes, these aren't correct in terms of placing these fractions on a number line. So despite the fact that they've got this understanding here, and they appear to have some understanding over here, they've got real issues with identifying fractions as numbers on a number line. So I've asked this question to quite a number of pupils, secondary, multi-composites, and so on, at all levels. And pupils often struggle with it. Sometimes they'll get it right, but not necessarily for the right reasons. They've maybe kind of been told things like the smaller the denominator, the larger the fraction, or something like that. But that only applies when all the numerators are the same if you're comparing those fractions. So it can be useful to give them a similar but slightly more challenging example to see what happens. So I've got lots of information. Like generally when I ask this question, most children don't quite get these right, but I do have some data from where we've done sort of more formal investigations on this. And from the pupils that I've asked here, only 20% of P7 pupils got both of those questions correct. And that's quite low considering the sort of, it's not that challenging a context for P7s. What's really interesting is this next question. So show where the number 1/2 would go on the number line and label this. So it's a number line deliberately labeled from 0 to 2. And most pupils put it here. So again, it's what are we meaning by these fractions? Yes, this is halfway along the number line, but if this is 2, then that isn't where the number 1/2 goes. You've got a pupil putting it here, another one sort of saying this place or this place, so halfway between the subdivisions. This one's similar to that first example, but they've also labelled quarters. But again, they're viewing the whole as the whole number line rather than kind of attending to the fact that there's this 2 here. So the percentage of pupils getting all 3 of these questions drops now quite dramatically to 7%. And again, although I've only got data from 2 different schools more formally, I've repeated this in lots of other places, and it's the same thing time and time again, whether this is primary or secondary. So the rest of the presentation, we're going to be looking at how we can support our pupils to understand different fraction concepts and the interconnections between them, including understanding fractions as numbers. We're going to look at this through the lens of different subconstructs of fractions. It's generally accepted that there are 5, but depending on what research you look at, that might be more or less. And we're going to look specifically at the quotient subconstruct and the measurement subconstruct, and look at the importance but limitations of the part-whole subconstruct. Again, if some of that doesn't make sense yet, hopefully it will as we go through. So just to introduce a bit of language in case you're not sure, the quotient is the result of dividing one number by another number. So in an equation like this is the dividend, this is divisor, and this is known as the quotient. If we're thinking about representations, this is probably the most common representation pupils see and deal with, and they tend to be pre-drawn. So all the kind of work about the equal parts is already done for children. They often get sets as well, but it's this final representation, the linear representation, that pupils often don't have a lot of experience with. And this leads us to placing fractions on number lines. And that's, again, what we're going to talk a bit more about in this presentation. So in terms of that part-whole subconstruct, the one that's predominantly explored, particularly within primary schools, what might pupils would the limitations be of it in terms of a question like this? Which of these represent thirds? And again, it's quite surprising the number of P7 pupils that will say that all of them represent thirds, because there are 3 parts. So their focus is on that parts. Those that can identify that those parts need to be equal in some sense might identify this one, but often won't identify this one. So you can see here that this part here is equal in area to this part here, which means all 3 parts are the same size. So again, can our pupils identify them in this variety of situations or just in specific situations? Another example, just to build on that in terms of that limitations of the part whole, these were 2 examples of equal sharing problems. This one's 5 children sharing 8 things. This one's 6 children sharing 5 things. And you can see here, this pupil's identified that each person gets 1 whole, 1/2, and then they've described this as 1/5. So again, thinking about why might they have labelled this as 1/5, and lots of adults label this as well. And again, if we think about that part whole, we're talking about how many parts here, 1, 2, 3, 4, 5. So that seems to make sense. And we can describe it as 1/5 as long as we explain what it's a fifth of. So this is 1/5 of 1/2 of 1 whole brownie. But if we're trying to kind of use it alongside these other ones, we need to describe it in relation to the whole. So it's actually 1/10. Same thing over here. This pupil's described this as 1/8 because there's 1, 2, 3, 4, 5, 6, 7, 8 parts and they're interested in one of them. So just to kind of make people aware about how this part whole understanding might kind of lead to misconceptions with pupils or gaps in understanding. So we're going to build through from the early years into the end of primary school and developing a sort of stronger understanding about fractions. So down in the early years, this was a trip to the woods that we did, focusing on mathematical language. It wasn't anything specifically to do with fractions, but the point of this one is that the kids started to measure one another using sticks of different sizes, so using that language of taller and shorter. So you'll see how this is kind of the building blocks of fractions as well, with this measurement idea. You can also see here that there are ways of extending these interactions too. So if pupils had come over with some sticks like this, you might say, can you find a stick that is 2 times as big as this stick? Or this stick is 1/2 as big as another stick. Can you find the other stick? I'm not saying this would necessarily be appropriate with these pupils, but just extending the sort of opportunities and discussion. This type of language with fractions isn't often used. So this was a story problem that was posed to a pupil in an ELC setting. It looks at the quotient subconstruct. So can you share these 5 grapes equally between 2 animals so that each had the same amount with none left over? The result is a mixed number. As an equation, it looks like this: 5 divided by 2 equals 2.5. I'm not suggesting for a minute that you explore these equations with pupils in the early years, but this problem is perfectly appropriate. And this type of thinking supports pupils to build an understanding of fractions as numbers from an early age. So this is what this pupil did. They're just over 4 years old. They gave 1 grape to a guinea pig, 1 to bear, 1 to guinea pig, 1 to bear. There wasn't a knife visible, and that was intentional, but they did say, can I have a knife to cut them? And then what they did was they took all 5 and cut them into very small pieces and started sharing them out, not necessarily equally. So they haven't been able to solve this problem in terms of, getting the answer of 2.5, but that isn't the point. The point is that they're starting to think, right, if I've got this extra bit, I can partition it and kind of cut it up so that I can have smaller bits to share it out. So we're developing this thinking. You will get pupils this age that are able to solve that problem. And this was in a P1 class. It's some water play. And again, this is building the foundation for their fractions knowledge. The measurement materials were just out for them, but there was no specific the children weren't tasked with anything specific, but naturally they started looking at how many times does this jug fit into this bowl, or how many times does this fit into this measuring cylinder, which, as you'll see, again, is the foundations of this fractions work. Again, this was a P1-2 class. The teacher had written out a recipe for Play-Doh. The pupils could come over and make this independently. So the unit of measure here is this cup, and then everything is referred to in relation to that cup. So they're starting to see the notation. They may not understand that, and that's fine, but they're beginning to get exposure to it. 1/2 of a cup. So this is that same problem that we had before, but we're now in a P1 class. And this pupil was about 5.5 years old. So they shared the 4 grapes, so they had 2 each. And then this dialogue is brilliant. This is what their sort of thought process. They can't share the 5th grape, so no one can have it. Or could we make a new one? There needs to be 6 grapes. They could share the grape if I could cut it in half, at which point they were given a knife. And then they said, now they each have 2 each and a half each. 2 of them there and 2 halves. So this pupil's dealing with mixed numbers, but in a way that's quite appropriate at the age that they are. And so they're starting to develop an understanding of fractions as numbers. So this pupil was then given this problem, 5 grapes between 4 people. They shared them out, and then with the kind of grape that couldn't be shared, they cut it into quarters. And then this language is brilliant. Now they have 4 little halves. So rather than focusing on what they can't do, look at what they can do. They have solved the problem. They have an understanding of the fact that these halves are different from the halves in the previous problem. They're smaller. So they're beginning to develop an understanding that quarters are smaller than halves, assuming we're talking about the same size whole. And they have put that as a number. They each have 1 and 1/2. The only reason this is wrong in terms of the half is because they haven't yet got the language, but you could start to model that as a teacher. I want to look at some early number lines as well, because this will play into what we're doing next. I want to emphasize this work was from some P3 pupils. This was just sort of experimentational. It wasn't sort of, it wasn't based on any kind of particular learning, but we had been looking at fractions. So can you make a stick that is 2 times as big as this stick? Draw it underneath. And then 3 times as big, 4 times as big. So the pupil draws the stick and then just draws 2 extra bits, 3 extra bits, 4 extra bits. This pupil draws this kind of original unit again on the end, but they're kind of obviously not quite sure about the size. Here it's different though, they've just extended it rather than drawing it as 3 separate units, but it is approximately the right length. And then here they've gone back to replicating the original unit. Same kind of thing here. And then I just want you to draw your attention to the fact that this pupil's realized that this last part isn't quite the same size as the others. So they've made an attempt to fix that. If we're always giving our pupils pre kind of cut or pre-created things, they don't have these opportunities to realize the importance of that. So as an extension to something like that, you could say, this is a 1 bar, can you draw a 2 bar? And then our role as teachers is to observe how pupils approach this. So do they place them side by side, draw them underneath and extend, or draw and replicate each unit? And does the pupil attend to keeping the size consistent? If they do, is this both height and width? So can they draw a 3 bar? And then can you draw a 4 bar? And then discussions like, you know, what do you notice about the 4 bar, or how does the 4 bar connect to the other one? So pupils might say it's 4 lots of the 1 bar, or it's double the 2 bar, or it's a 3 bar and a 1 bar. So this is the beginning of composition and decomposition, but building our understanding of fractions. That's our kind of goal here. So you could then start to link this to the number line by using something that's kind of familiar, that's maybe rectangular in shape, and that would be kind of logical to subdivide. So these rectangles could represent chocolate logs, chocolate bars, brownies, something like that. And then we're going to attach this onto a number line. So at this point, there are no brownies. And then we've got 1 brownie, 2 brownie, 3 brownies, and 4 brownies. If pupils' experiences are around these sort of regional representations, we can use those to build into the number line representation. Notice that in this one, the whole hasn't been partitioned into 8 parts and then we've coloured in 7 of them. We've got 7 units of 1/8. So that is quite a different kind of idea there. And then here, it hasn't been partitioned at all, but we've now got 1 unit of 7/8. So we're going to look at developing the measurement scheme for unit fractions now. We're going to look at a context-based problem. I've picked Miles the tortoise. He's a pet tortoise at one of the schools that I work at. So the context will be kind of relevant and the pupils will be able to connect with it. So my question for the pupils is, how can we describe how far Miles walked at different times of day in relation to 1 meter? I'm going to make sure my pupils have got a concept of what 1 meter looks like, and I'm going to provide them with a 1 meter length. So something like till roll is quite useful for this. It's cheap and doesn't matter if it kind of gets messed up and stuff. So if Miles traveled this far, how can we describe this in relation to 1 meter? And after each of these, you're going to have kind of discussion, compare different strategies for solving this problem, and then look at different lengths in addition to that. So observe how pupils attempt to solve this and reason about this. So do they use estimation strategies? Well, I wonder how many times that fits into 1 meter, maybe 5 or 6 times. Maybe they start to think about a measurement strategy. So looking at kind of, can I measure this length using this, but they're maybe not doing it very accurately and leaving these gaps. Maybe they're iterating the given unit more accurately, so placing it, maybe putting their finger down and moving it along here to see how many times it fits in. So it is important to build this measurement idea that they only have one copy of this unit rather than lots of them. So here we're building that understanding of something being iterated or fitted into the whole. Another way that you'll see is pupils marking off these units, moving it along, marking it again, and so on. So through this understanding, they'll start to make sense of what's going on here, and you'll have children saying, this strip will fit 2 times into 1 metre, miles travelled 1/2 of a metre, and you might get some pupils using the fraction notation here as well. And then they'll start to build the connections with other unit fractions. They've seen that this fits 5 times into the whole, and this is, so miles travelled 1/5 of a metre. And again, you might get different notations for that too. So this type of context can help us understand this inverse relationship between partitioning and iterating. So pupils start to develop a sense that in order to get that 1/5 part, the whole might have been partitioned into 5 equal parts, and each part is the size 1/5 of a metre in this case. And then in order to recreate the whole, they need 5 lots of those 1/5 parts. And so now we're starting to build up this idea that 5/5 is equal to 1 whole, but with that kind of inverse relationship between partitioning and iterating. That's the key point there. So again, this is back with the P3s, and again, this was just sort of experimentational, but I have done some work with them on halves, thirds and quarters. And so they were told, if this piece of chocolate is 1/2 of a bar, can you draw the whole chocolate bar? So looking at moving from part to whole, we often move from whole to part. So here the pupil seems to have made some sense of that. It's slightly too big, but otherwise it's pretty accurate, and they've just extended it, but they've not managed to do it with these two. This pupil, they cut the original one in half, but then they seem to have made sense of the problem, and they've repeated that 1/3 unit 3 times and this 1/4 unit 4 times, recreating the whole. This pupil's done something similar, but for that first one, they extended it there. Again, there are kind of things that we need to pay attention to in terms of the consistency of size, and those are the things that we're needing to draw our pupils' attention to, and that sometimes are missed opportunities with always using things that are cut to exactly the right size. I'm going to move onto the quotient subconstruct just briefly. You'll see I go back and forth between these to kind of continue to develop this understanding of unit fractions, but also understanding of this reciprocal relationship between the number of equal parts in the whole and the size of each part. So the problem that the pupils had was 1 cake shared between 2 people, 1 cake shared between 6 people, and so on. So you see from the drawing, one of the difficulties in doing this is that all these holes are slightly different sizes. So actually, if we're comparing them in this drawing, 1/2 is probably smaller than 1/4. So again, those are important discussions to have with the pupils, so they appreciate the importance of the size of the whole when we're talking about fractions. Through this type of work, you can support pupils to create this sort of generalized understanding of the greater the number of sharers or parts, the smaller each part will be, assuming we're comparing the parts to the same size whole, but without just telling them that and kind of getting them to accept it, just using a kind of numerals as opposed to actually from a point of view of understanding. So we already looked at kind of creating this number line with whole numbers. And then after this experience with unit fractions, we want to be placing that onto our number line as well. If I understand where 1 goes, and this is what 1/2 looks like, where does that fit on the number line? So that pupils are starting to identify these fractions as numbers. As well as doing it with fractions less than 1, we've seen that the kids in P1 can solve problems that involve mixed numbers. So as they get older and they start to look at these unit fractions and things like that, when it's appropriate, they can also be putting these mixed numbers on a number line as well. So this might be around the sort of P4 range, perhaps P3 for some pupils. So if we go back to this question that I gave those pupils right at the beginning, they can make much more sense of this now through those problems. They have a better understanding about the relationships. So we're going to go back to Miles the tortoise in this context again. I want to kind of emphasize here that for some, depending on the kind of age and stage of your pupils, it might be that you've stopped at that unit fraction sort of part there, and that's you just explore more things around there. But for some pupils, you might extend this now to developing a measurement scheme for proper fractions. So we're going to be using the unit fraction as a unit of measure now, and children will start to do this quite naturally if they've had those other experiences. So we're trying to find out how far Miles has travelled in relation to 1 metre if this is the distance he's gone, or perhaps this is the distance he's gone. So again, allow pupils to experiment with this, compare it to their 1 metre length. They'll come up with things like it doesn't fit an exact number of times into 1 metre, it fits 2.5 times into 1 metre. Then they might start to make connections such as, I wonder if this piece would fit into that gap. So these are the same pieces, they're available. They've used them before in the previous problem about unit fractions. And then they start to make connections with this idea, oh, I wonder how many times that will fit into this piece I've got, and see that the 1/5 of a metre piece fits 2 times into this piece. So pupils are then able to talk about 2 lots or 2 measures or 2 units of 1/5 of a metre. So this is how long this strip is. They start to be able to move into notation like this, so adding unit fractions and also multiplying a whole number by a unit fraction. But and what tends to happen is the pupils don't make that mistake that we see so often with both primary and secondary pupils, where they say this is 2/10 because they've just added these. That doesn't make sense to them if they've built up their understanding through these contexts and situations, and they're using the unit fractions as a unit of measure. They don't need to be taught an algorithm. The understanding comes out of the problem. So Miles travelled 2/5 of a metre, and again, there's different ways they might record that. So just a note on the kind of fraction notation there, it's important to realise that the denominator and numerator will mean different things in different within these different subconstructs. So within the measurement subconstruct, this 5 as the denominator is a fractional unit. We're talking about how many times that part fits into the whole. So we're talking about units of 1/5 in this problem. And then this numerator is a counting number. It's how many of those fractional units I have. So in this case, I've got 2 units of 1/5, which is 2/5. So pupils are able to deal with this type of thing if they've built it up through these contexts around about the sort of P4, P5 age range. We're back to the quotient subconstruct here. Before I go on to look at some pupils' drawings, I just want to look at some limitations of just teaching through algorithms and things like that, but without getting pupils to make sense of what's going on. So here the problem that the children have got is 8 children share 6 chocolate logs. And you can see here that the pupil has divided the numbers in the order that they appear in the problem. So 8 divided by 6. Rather than actually making sense of the problem, which is asking 6 divided by 8. You can also see that based on the pupils working out, so this isn't correct, but based on their working out, their answer should be at least 1. But you can see from the fractions that they've written that they've just kind of taken these numerals that appeared in their answer, popped them into a fraction and kind of, that's the answer. But that doesn't make sense in relation to things that they've got there. So they don't really seem to have an understanding of division, of fractions, and so on. And it's not that they're not capable of doing that. It's just that they're coming at it from trying to apply a procedure to something that they don't understand. There's no reasoning or estimation here. So the types of things that you want children to start reflecting on is things like this. I know the answer is going to be less than 1 because there are fewer chocolate logs than children. If I kind of estimate and say, right, they each get 1/2 of a chocolate log, that would be 4 chocolate logs. I've got 6, so there must be more than 1/2. if you explore these types of problems through kind of drawings and making sense of the problems, pupils start to develop this a lot more easily. And you can see this measurement subconstruct coming into play within these quotient subconstruct examples, these equal sharing problems. So 8 children share 7. You can see the pupils divided each one up, and now he's saying that everyone gets 7 1/8 pieces. So one here, one here, one here, 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 and here. So one person's share is 7 1/8 pieces. This pupil didn't use this notation here, but again, as I said, it tends to come quite naturally out of this. And it's easy for pupils to make sense of in this context in terms of adding unit fractions and then applying this to multiplication as well. This is a same class, same problem, but a pupil solved it a different way. So no strategy has been imposed upon them, and the thinking is all the richer for it. And you can discuss these different ways and what understanding it draws out. So this pupil, they're saying that each person gets 1/2, 1/8, plus 1/8, plus 1/8. And you can see here, they've then said, right, well, that's the same as 4/8 plus 1/8 plus 1/8 plus 1/8, which is the same as 7/8. So this pupil is adding fractions with related denominators. But again, we haven't gone near an algorithm in terms of multiply top and bottom by the same thing. They're making sense of that through their experiences with these problems. I'm not going to go into equivalence and kind of more detail on this type of addition because it needs a presentation in its own right. But I just want to emphasize that this comes very naturally out of this type of work. There are issues with the drawing, and again, I would see that as, you know, a reason to get the pupils to generate this rather than giving them always sort of manipulatives and things like that with the fractions. This one whole is quite a bit smaller than this one whole, so are we able to sort of add these in the way that this pupil has here? Same kind of thing here. The pupil's got 3/4 and 1/8, and they've managed to work out that that's 7/8 as well. So just like before, we're going to extend the number line. We're going to use those problems and then think, you know, if this is 1 brownie, where does that number fit on our number line? Doing that with fractions that are equal to 1, non-unit fractions that are less than 1, but also extending to these mixed numbers as well. So if we go back to this problem that I posed right at the beginning, and again, we're looking at now from all that kind of richer experience and asking the pupils, what patterns and relationships do you notice? So types of things that they might come up with is that for each fraction, the numerator is smaller than the denominator. They might say they're all less than 1. They're all larger than 1/2, so they're starting to use benchmarks. The numerator is 1 less than the denominator. That's pupil language there. They're all 1 part away from the whole, or maybe a more formal definition of that, they're all 1 unit fraction away from the whole. So pupils are actually making sense of this now rather than just kind of applying something that they've been told. So if they're reasoning about this, you know, they might know that 1/10 is smaller than 1/3 because of that other experience that they've had with unit fractions, and they can apply it then to this problem to reason that, well, as a result of that, 9/10 must be closer to 1 whole than 2/3 is, therefore 2/3 is actually smaller. And then they can go on to put the rest of those in order. So we're back to Miles the tortoise again, and we're now looking at a generalized measurement scheme for fractions. So we're moving into improper fractions here. This type of work would be appropriate for your sort of P6s and P7s if they're sort of if they've had these prior experiences and they're sort of typically developing. So now we've got a strip that's longer than 1 meter. So how are they going to do that? Again, we're going to think about some limitations of part whole when we start moving into improper fractions, and this understanding that this requires 3 levels of unit coordination. So just thinking about that part whole issue a moment, if we're asking a pupil's question like this, how big is 1 red rod in relation to 1 orange rod? Or perhaps we're asking them, how big is the red part in relation to 1 orange rod? Pupils whose experiences of fractions predominantly relate to the part whole subconstruct will be thinking along these types of lines. How many parts has the whole been split into? How many of those parts have you got? but they may have difficulty identifying what fraction the red part is, because they're looking at the number, like how many parts there are, and they lose sight of this whole. So common incorrect answers to this include that this is 1/7 because there are 7 of them, and that this is 7/7 because it's 7 lots of 1/7. If pupils happen to get this right and correctly identify that this is 1/5, it can be interesting to then ask them, what size is this piece in relation to the orange rod, or in relation to one whole? And lots of pupils who get this right will then go on to get this incorrect. They'll say this is 1/7. But if we've built up that measurement subconstruct, we can ask them, how many times does this fit into the whole? And they'll realize that it fits 5 times into the whole. Therefore, this is 1/5 rather than 1/7, because we're comparing it to this. If I was comparing it to the entire red part, then sure, it's 1/7, but that isn't what the question was asking. So coming back to this and trying to look now at this 3 levels of units coordination, our pupils have already made sense of unit fractions. That's one level. Our pupils have also made sense of how many of those unit fractions fit into one whole. That's our next level, what the whole is. So 5 units of 1/5, or 5 lots of 1/5. Can I just double check you can hear me? I think I got muted there.
I can hear you, Sarah.
Perfect, brilliant, thanks. Okay, and then this 3rd level is extending beyond the whole. So we've got 6 units of 1/5, or 6 lots of 1/5, or 6/5 of a meter, or 1 1/5 of a meter. And we can start to extend our recording from before to 6 lots of 1/5 equals 6/5, or kind of flexible recording like this, 5/5 plus 1/5 equals 1 plus 1/5, which equals 1 1/5. I want to emphasize again that this type of recording and understanding comes quite naturally out of this type of work, and pupils are able to develop a much better understanding of addition, subtraction, and also multiplication and division of fractions. In terms of converting between mixed numbers and improper fractions, pupils that have done this type of work don't require a kind of procedure or an algorithm to do that. They kind of more implicitly understand the relationship between how many units make up the whole, and so how to make those calculations. So again, this is around P6, P7 type of range. And again, we're going to be looking at putting those onto a number line. So we did it with the whole numbers, we did it with our unit fractions, we did it with how many make one whole, our mixed numbers, and now we're going to add our improper fractions. So we can start to see now that 2 2/3 is the same number as 8/3. They're just represented differently, but they occupy the same space on the number line. So I just want to revisit this P1 who solved this problem. And again, this isn't atypical. This is perfectly within the reach of our P1s. And so we shouldn't avoid exploring fractions with these younger pupils. But I want to emphasize that this P1 had started to make sense of fractions as numbers. They did solve the problem through action, and that was appropriate for this age range. The pupil wasn't engaged in 3 levels of units coordination like we just looked at. So the pupil was expressing the solution of the problem as a mixed number rather than an improper fraction there. So just kind of going to finish off revisiting this quotient subconstruct. Just as a reminder, the quotient is the result of dividing one quantity by another, and looking at some more of these equal sharing problems, as well as that kind of interconnection between the measurement and the quotient subconstruct. So and I emphasize the plenty of experience here, with plenty of experience reasoning about and solving equal sharing problems, not strategies imposed upon them, but really careful discussion based on the work that they're producing. The pupil's thinking and recording naturally becomes contracted to reveal that quotient subconstruct, so fractions as quotients. And lots of adults haven't kind of grasped this understanding, not because they can't, just because they haven't had these types of experiences. So we saw there the pupil cutting all the parts up into all the holes into 8, and then they get 7 1/8 pieces. Similar type of thing here, but the pupils kind of identified just one of person's share. We saw that at the beginning. So also 7/8 of one brownie. What's really nice here is this pupil used to record in that type of way, but now through experience, they realize, oh, actually, you can see it halfway through the problem. I don't need to do that anymore. I understand, I know exactly what's going to happen here. So they kind of draw these other bits out, and they know that the result is going to be 7/8 without having to draw out the whole problem. And then here, same kind of thing, but this pupil's gone one step further. They've identified the equation that corresponds with this, and then they've identified the fraction that's a result of that problem. So they start to see, all right, 4 divided by 11 equals 4/11. And then they'll start not needing to do these drawings at all and just be able to move straight into that. I do want to emphasize that however tempting it is to just move straight to this point, if you do that, pupils probably won't really understand it, even though they'll be able to get an answer, but you would have also missed out all those other rich opportunities to really get to grips with unit fractions, non-unit fractions, but also all the addition and subtraction and equivalence that goes alongside pupils' drawings here. So don't be tempted just to kind of force feed them this and rush to that point. So just as a summary of kind of what we've looked at common difficulties that pupils might have, as well as adults in terms of their experience with working with fractions, and we've looked at what we can do about this. We've started to understand the meaning of fractions and whether they all mean the same thing or whether they represent different things in different situations. And we've also looked at understanding fractions as numbers. We started to explore that measurement subconstruct for fractions and the interplay between that measurement subconstruct and other fraction subconstructs, like the quotient subconstruct, for example. So I'm going to hand over to Andy just briefly, and he's going to talk about the future and kind of what next.
That's great, Sarah. Thank you very much. Sarah mentioned equivalence earlier, and she said that we didn't touch much on it during this presentation because it could do with an entire session on itself, and I have put in the chat that maybe at some point we would like to do something on that. So between everything that Sarah's talked about and developing equivalence, we would see that very much as the bedrock of what we would be expecting most learners to be doing by the time they finish primary 7. And we're trying not to assign too much around levels, but really when we get to the end of level 2, that the idea really is that we would be looking for learners to have gone past the part-whole scheme into the measurement scheme for unit fractions, which I've put in the chat would really be around the end of level 1. So by the end of primary 4, moving then into primary 5, 6, and 7 is the measurement scheme for proper fractions, building towards the general measurement scheme for fractions that Sarah talked about. And that, of course, then opens up that richness around developing mixed numbers and proper fractions and everything. So what we're looking at now is the kind of key transition point, because given obviously that the move for learners from the end of primary 7 into S1 is obviously a big stage in their lives and their development. It's looking at how we can bring the primary and secondary together around that standard in order to make that move for most into level 3 to be a bit more smooth. And thinking then about level 3 and indeed level 4, the two subconstructs that Sarah didn't mention because we wouldn't really be expecting much to be done with them in primary school. There's the idea of the ratio subconstruct, and I've listed here the operator subconstruct, which is the final subconstruct, and that really has to do with the multiplicative reasoning that comes with fractions. So whilst we can think of something like 3 times 1/5 as a multiplication involving a fraction, if we were to turn that around and think of, well, what's meant by 1/5 times 3, that's, although that you get the same answer, the 1/5 plate assumes a different rule, and the answer is still the quantity or the measure of 3/5. but the operator subconstruct is a way of actually viewing that multiplication by a proper fraction as a kind of scaling. And that notion of scaling is absolutely pivotal for lots of work in the secondary school. So examples including work with similarity, similar triangles, trigonometry, even the basics of direct and inverse proportion and linear graphs. It absolutely permeates so much of secondary school work, and that's why it's so important to develop. So looking at making the links across the subconstructs and also thinking about fractions relating to decimals and percentages. And of course, as I mentioned earlier, if we're going to make numeracy across the curriculum really come alive, it's really important that that measurement idea comes into the work that our learners do around fractions right across the board. So this is where we're going, and this is where we hope to take things. I've put all our details in the chat. Please feel free to email me if there's anything else that you want. And thank you all very much for turning up today. It's been a pleasure to be invited. Thank you.
Thanks, Andy, and thanks, Sarah. That was really fascinating as always, with loads and loads of food for thought.